Hi, welcome to yet another release of Dogen. This time we're in Sprint 20, version 1.0.20, Oasis do Arco. This is a bit of a quiet release, I guess, from a perspective of a demo, because really the only features that we have in this release are all sort of side effects of the work on the relational model, and we just decided to expose some of these features to the end users. In order to make the most of it, since this is going to be such a quick demo, I decided to change the format slightly for this demo. Instead of using a demo model, I'm actually going to show you the actual Dogen test models, so you can see really how we normally use Dogen. I've avoided doing this up to now because I wanted to show you simple, non-complicated ways of using Dogen to make it easier to get you up and running. However, I think it's also useful to see how a big model looks like and how it is really used in practice. So without further ado, let's have a quick look at the features. So the first one was changes around type overrides. So what we'll do is we'll hop over here to our dia. We're using a very large version because this is how we normally develop. For the demo purposes, I tend to make the screen a lot bigger. But today I want to show you the full sort of sizes of the models that we use. So if we take something such as the relational model, what you can see here is the types that we're using to generate the database tables in Postgres. And each these types here in purple is a primitive, a Dogen primitive. A few of these primitives have a type mapping on them, particularly the JSON one. So you can see here is in our JSON content, which is sort of the owner, sort of the object input that owns JSON, we define the field of type JSON. And then in JSON we use the new type mapping. So I'll just expand this slightly, we can see a bit better. It's a shame you can't expand this field here. So as any primitive has to have, here we've got sort of a definition of what's the underlying type that the primitive is based on. In this case it's just a std string. And then we have a type override. This just uses the sort of syntax, or closest possible to the syntax UDB uses. In this particular case we're mapping the type JSONB for the database type Postgres. And then we're overriding the type. And then in the type mapping, we show what functions were used to convert to and from this type. So in other words, how do you go from a string to JSONB, and how do you go from JSONB to a string? And that kind of teaches Postgres how to do it. And for good measure, we also do the same thing for SQLite, though to be fair, we're not using SQLite just yet, but it's something we could in the future do. And that's pretty much it. The key difference is that, as you can see here, you can now define your type mappings up front, and then you can make use of the type mapping just like you did before. Now, we chose to use a primitive here, but of course nothing stops you from defining these type mappings in a class. For example, we could define the type mapping here, interest from event. However, because we use JSONB a lot, so as you can see here, there's field of JSON here. We factored in the commonalities to a primitive, and we created an object template. It just makes it a bit nicer. And then, for good measure, if we have a quick look at the generated codes, we can just hop over to the relational model. If we take something such as the transform events, VP, as you can see here, and if you look for the ODB pragmas, this is actually for the key. We want not the key, but well, actually we want the primitive. So as you can see here, the generated codes contains the type mapping using the sort of the pragmas that ODB expects, and this is defined in such a way that hopefully it will be portable to other ORM mapping tools. Though of course Dogen doesn't use any other ORM mapping tool, but hopefully at some point we'll be able to ensure this is fairly generic. And I guess that's about it. Then of course, as always, the ODB pragmas then give rise to the sort of the ODB code. So after you run ODB, ODB goes away and generates this code specific to the database. This is just basically what ODB codes. We haven't touched any of this. It's just making use of the mapping now. And that is the first feature. There is a separate video that we're going to do talking about the relational model, so I'm not going to get too much into details of how these things actually get used. So for that, please check the other video in the series of the relational model. So that was the first feature. And then the second feature, this was also done purely because we needed this for the relational model. We needed a way of uniquely identifying model elements in a set of models. So the easiest way we found was to just create a SHA key. But it then occurred to me that perhaps it would be useful to expose this in terms of the decoration. So if you want to annotate your generated files with a SHA key, for instance, if you want to track what model was used to generate what files, purely for informational purposes, as I say on the release notes, then you can do it now. So let's have a quick look at how you do that. So for this, we can use the C++ reference implementation. And as you can see here, we've modified C++ reference implementation to have this new key, which is the original SHA key, SHA-1 hash. And just set that to true. And then we generated the files for this model, which you have here in this area. And the result, hopefully, is, as you can see here, every file now has an entry with the SHA key for that model. Now this particular model is the LAM model. I'll show you what the LAM model looks like for a good measure. Which is this chap here. It's a very, very simple model. What we'll do is just to confirm that Dogen is doing the right thing is we will just hop over to a shell. Hopefully you have a shell somewhere. We don't, so I'll just create a new one. Hopefully. The demo gods are with us, and they are. So what we'll do is I have a shell here, and if I just locate the C++ reference impl and integration, and if you just go to projects, around here we should have models somewhere. There we are. And in there we should have the dia models. So just locate the dia model. If I just run SHA-1 sum on the dia model, I get this number. If all's gone according to plan, this is this number, and as you can see, it is correct. So to recap, as explained in the release notes, you can just run SHA-1 on the current state of the model, and it will give you SHA-1 sum. It will give you the hash, and Dogen uses a similar approach to stamp the algorithm. So that is all for the SHA-1 in hash decoration. And finally we have the improvements in generation timestamps. Now of course we already had generation timestamps. All you need to do is to set the date time to true, and as you can see here, oh actually we haven't generated this since we set it to true. For good measure, let's just set it to true, because as you can see we're using the basic generation marker. And then if I go over to the LAM model, which we had a second ago, hopefully still here. Go to the LAM model, you can see that the profile is basic. So what we'll do is we'll just generate all models, and that's done. And then you can see the timestamp is being generated here. So the key thing about the timestamp now is that if I open up any of these files, all of them have got exactly the same timestamp, because we now have a single place in which we get the timestamp from. In addition, if for whatever reason you need to fix the timestamp, it is now possible to just set it from the activity timestamp parameter. So if I now check this chap here, hopefully we'll see that it's 12:45:33, and as you can see it's exactly the timestamp we set in the command line. And that's just basically because this chap here is now being used. And I believe is about it for this sprint. So it was a very, very important sprint for us, but mainly due to the features that we worked on the relational model, which sadly are not user-facing features. But if you're interested in that, please have a quick look at the relational model series of videos. The last one is just going to summarize the whole series, so maybe you can just watch the last one. Thanks very much for watching.